Hello and welcome to today's lesson. Before we start, for this lesson you will need a pen, a ruler, a calculator, some paper or an exercise book, and no mobile phone unless you're using this to view the video on. Best off, remove any distractions. If you need to pause the video to go get the equipment, then please do so now. Welcome to today's lesson, where we will look at electromagnets and magnetic fields. We are continuing with our topic on how do magnetic fields produce electricity, but in today's lesson we're going to look specifically at how you build an electromagnet. First of all, something to get you thinking. Can you explain what is happening here? 30 seconds. So in both of these images we have got magnets and substances which are magnetic, and they are being attracted towards each other. So thinking about bar magnets, which you will have looked at in year 7, can you say what would happen to the magnets in each of the following scenarios? So I've put the poles on the magnets. What will happen to each pair of magnets? 30 seconds. Okay, so in the first one we've got two north poles together, so they're going to repel each other and the magnets will move apart. In the second one we've got opposite poles, so we've got a south and a north facing each other, so they will attract each other and join together. And on the bottom one, similar to the top, we've got two similar poles, two south poles, so they will repel each other. So what does the word electromagnet mean? So electromagnet is a magnet produced by an electric current. I'm going to have a look at a short video now.
Okay, so let's have a look at the magnetic field around an electromagnet. So we'll make an electromagnet first. So all you need is any piece of steel. You could use a nail. I'm just going to use this tool out of the garage. So we got that for the core, C-O-R-E, and some insulated wire that I've just taken the plastic off the end. I'm just going to wrap it round, and as I wrap it round I'm just going to count the number of turns. 1, 2, 3, 4. That's 10. 15, 16, 17, 18, 19, 20. I'll go back the other way. 21, 32, 33, 34, 35, 36, 37, 38, 39. Got 40. I'm just going to twist it, stop it coming off. So we've got an electromagnet, iron core, and some turns around there. 40. Then we need a current through it. So from a power pack, positive connection on there, negative on there, not switched on yet. Got some paper clips, I'll put them close, switch it on. Okay, so now it just is like it's a permanent magnet. So what we've done is the magnetic field around and inside the coil has made an induced magnet in the core.
So any wire that has a current flowing through it has a very tiny magnetic field around it, and if you coil the wire it will make the magnetic force stronger, and we call that a solenoid. When we turn the current off, the magnetic field will disappear, and that's basically what an electromagnet is. It's a magnet that we can turn on and off using electricity. Okay, so I've got a few sentences here with some missing words and the words at the bottom. So I'd like you to complete the sentences using the words at the bottom in red. 3 minutes. How did we get on then? So when an electric current flows in a wire, it creates a magnetic field. By winding the wire into a coil called a solenoid, we can strengthen the magnetic field. The strength of the magnet can be increased by wrapping the wire around an iron core and increasing the number of coils around the core, or increasing the current flowing through the wire. If you didn't get any of those, you need to pause the video to complete that. Please do. So thinking back to the video, could you describe how to make an electromagnet? I'm going to give you 2 minutes to do that. Okay, so first of all we need to create a solenoid by coiling the wire, and then we connect each end of the solenoid to a power source. That could be a power pack or a battery, and then we turn on the power source to allow electrical current to flow. And if we wanted to, we could strengthen the electromagnet by putting an iron core in the middle. Now, when you're in year 7, you will have plotted magnetic fields from a bar magnet like so. And I'm just going to show you a short video to remind you how we plotted magnetic fields.
So that's called a plotting compass. All it is a very small permanent magnet that's just sat on a pin so that it can rotate. And what that will do, it will line up with the Earth's magnetic field. So at the moment, it's pointing, probably a bit difficult for you to see, it's pointing in that direction, which in my kitchen is north. North, east, south, and then west. And I've got lots of these. And all of these, because I've checked, all point in the right direction, and then they'll all point north. So I've got lots of them. So what we're going to do now, we're going to use those to plot the magnetic field around a permanent magnet. But this time we're not just looking at the pattern, we're looking to get a direction and more detail. So if an exam question asks you how you would plot a bit like a graph, the magnetic field around a permanent magnet or anything else, you do it this way using a plotting compass. So what I'm going to do, I'm going to put loads of these. If you were doing this in class, you'd probably just have one and you'd move it around. So what I'm going to do is I'm just going to get loads of them. I'll put them in some sort of pattern in a minute. Be looking at the way that they're facing now. So this permanent bar magnet, the magnetic field here, close around it, is a lot stronger than the Earth's magnetic field, so we can ignore the Earth's magnetic field. What these plotting compasses are now going to show you is the direction of the magnetic field around it. So I'll just take them slightly out of the picture a bit. Okay, so what I'm going to do now, I'm going to take each one off and I'm going to put down an arrow representing the way that it was pointing before. A bit of a pattern forming there. Put one there. And if I carry it on further out, choose one, make it less complicated. So I've got that pattern over here. Okay, just going to get these out of the way. I'm just going to go with one now. So, what we've got arrows coming out of the North Pole and arrows going in to the South Pole. I'm going to join these up now. Okay, let's carry it on. Carry it on. Round there. Okay, so now we've got the magnetic field drawn. So drawing something like that will get you 2 marks on the exam. But points to note that make it a bit more useful to you. The magnetic field is strongest where these field lines are closest together. So you can see that the magnetic field is strongest at the poles. We fill in those lines there. You can see the lines are getting closer together as they go into the poles. Down the sides, you can see that the lines are spread further apart. If I were to draw another one in, you can see out here, it would be getting weaker. So, where the lines are closest together, magnetic field is strongest. Where the lines are furthest apart, the field is weakest. It'll get weaker and weaker and weaker as you go further away from the magnet. And the magnetic field lines go in a direction as two, so you need to mark a direction, and that direction is always from north to south. It's the way that you'd say it, and in alphabetical order, the magnetic field lines go from north to south.
So you will be used to having magnetic fields that look like that, with the field lines going from north to south, and the closer they are to the ends, the closer they are together, and as we go away they get further apart. You may have also plotted them using iron filings, and again we get the very, very similar pattern.
So now we've got something called a solenoid, not a word that you're going to see very often, probably the once when you do your science exam. So we're still looking at the magnetic field around a current carrying wire, except instead of the wire being straight, it's been turned into a coil. So it's just coiled round, and in the middle of it we've got perspex so that we can use the plotting compasses again to look at the magnetic field. So we've got the current coming out of the positive terminal, red wire, flowing along there and going round. So the bits of the wire that are closest to the camera there, as you can see, the current is going that way. So each bit of these wire that you can see, the current is going that way. And if you were to look underneath, the current would be going the opposite way because it's going round. So what we're going to do now is turn it on, so we've got current flowing through it, and we'll have a look at the magnetic field around it by using the plotting compasses. At the moment, they're all pointed pretty much roughly that way because that's north. So I'll switch it on, have a look, and we'll plot the pattern. So that one's pretty much stayed in the same place. So we've got the field on that one, so I'll take that one off, is that way. And I'll do the one on the other side as well, so that's that way. So the field is going in at that side, out at that side. So here it's like that, and it should start to look familiar. Now it's going to have to wait a little bit just because it's overheated and the fuse has popped out, but it will be symmetrical. See if I can get it to come back on. Yeah, so it's going that way, that way, that way, that way. Right, just going to switch it off, let it cool down. So joining them up. Look familiar? Should do, because it's just as if we've got a bar magnet there. It's just like I had that there. So if I had room, be going round like that, round like that. I can do one on that side. So, what's the field pattern tell us? It tells us that here the field is strongest, here it's weaker, and it goes from there to there. And remember, the arrows always point from north to south.
So as you can see then, the magnetic field around an electromagnet looks just the same as it does around a bar magnet. Okay then, can you suggest any advantages of using an electromagnet rather than a bar magnet? Well, one of the main advantages of an electromagnet is that you can turn it on and off, so it's not magnetic all the time. And another advantage is that we can make magnets that are much stronger. Well, that wraps things up for today, so thank you for listening, and I'll see you again in the next lesson. Bye!